In this video, we're going to look at an introduction to trigonometry and how we can use trigonometry to find missing sides in right-angled triangles. Trigonometry is concerned with the relationship between angles and sides in right-angled triangles. We want to look now at three different trig functions: sine, cosine, and tangent, and how they relate between the sides and the angles of triangles. Before we get on to looking at our sine, cosine, and tangent, what we want to do first of all is look at how we label these triangles. So, very important how we label the triangles. If 38, for example, here is my marked angle, and also I've got a right angle, and so it's a right angle triangle, then relative to the 38 degrees, this side here, from A to E, this side here is, or A to B, sorry, is labeled the opposite side. Okay, and beside the 38, and another word for beside is adjacent, or adjacent to, this side then is labeled the adjacent. And the side which is the longest side of the right angle triangle, or another way of thinking about it is opposite to the right angle, is called the hypotenuse. So opposite is opposite the angle that is given, adjacent is beside the angle that's given, and the hypotenuse is opposite the right angle. Same idea in this triangle. Here 25 is a given angle. This side here is opposite to 25. This side here is adjacent to the 25, and this is opposite to the right angle, so this is the hypotenuse. In this last triangle, 65 is a given angle. The opposite side is down here, the adjacent side is here, and the hypotenuse is here. So it's important that we're able to label these correctly. And we'll be abbreviating these. Instead of opposite, you're going to write capital O. Instead of adjacent, you're going to write capital A. And instead of hypotenuse, you're going to label it capital H. This first example says, draw triangles PQR, where Q is equal to 90 degrees, R is equal to 27 degrees, and what is the name of the sides PQ, PR, and QR. So just pause the video, I'll draw a wee right angle triangle, and then we will label it. Okay, so we've got my right angle triangle. It tells us, first of all, Q is equal to 90 degrees, so there's our right angle. I'll mark that as Q. It says R is equal to 27, so there's my R. I'm going to say it's 27 degrees, and it was PQR, so there's my P here. And it says, what are the names of the sides of P to Q? So P to Q is this side. So relative to the given angle, it is my opposite. My PR is this long one. It's opposite the right angle, so it is a hypotenuse. So you see I've abbreviated those to just H and O. And QR is beside my given angle, so it is A for adjacent. So we'll just say, write those down. PQ is, PR is, and QR is, and then we'll just fill those in with the correct words. So your PQ, you can see it was the opposite. So just label it opposite. PR is the longest one, so it's the hypotenuse. And QR was the adjacent. And that is it. Okay, these things, what we're going to look at now is how we can use our sine, cosine, and tangent. So if I just draw a very quick right angle triangle again, and I'm going to label the angle theta. This is my opposite, that's my right angle, sorry, that's my opposite, that's my hypotenuse, and that is my adjacent. Now we're going to use a very good memory tool, which is Sohcahtoa. And this will help us remember all of our what's called trig ratios. So the things I'm going to give you now are the trig ratios. So sine of the angle is equal to the opposite over the hypotenuse. Okay, and we can abbreviate that to sine to SIN. Don't call it sin, it's not sin, it's sine. So if you see SIN in mathematics, it's sine. So sine theta equals O over H. Next one is cosine. Cosine theta is equal to adjacent over hypotenuse. And how it could be abbreviated is cos theta is equal to capital A over capital H. And the last one is tangent theta is equal to the opposite over the adjacent. And it can be abbreviated to tan theta is equal to O over A. Now that's an awful lot to remember, but luckily this thing up here helps us remember. So Sohcahtoa helps us remember all of this. So if you want to find, if you're given two sides, so for example you're given O and the H, what you would look for the one that involves O and H, and it is sine. So sine equals opposite over hypotenuse, which is what we have. If you had a triangle and it had the adjacent, and it had the hypotenuse, then you would use cos. So cos theta is equal to A over H, so cos theta equals adjacent over hypotenuse. If you had a triangle and it had the opposite and adjacent, then you would use tan. So cos tan theta is equal to the opposite over the adjacent. Okay, here we have all of our trig ratios all summed up. So in right angle triangles, the ratios of any pair of sides in one triangle is equal to the ratio of the corresponding pair of the others. So, okay, so that's fairly complicated sounding, but all we're looking at is our Sohcahtoa here. So if you've got your O and your H, you use sine. If you've got your A and your H, you use cos. If you've got your O and your A, you use tan. And how you remember it is Sohcahtoa. So sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to O over A. And I've said this already, but just to remind you, these things are called our trig ratios. So if it said find the trig ratio, this is the sort of thing they're looking for. We're going to look now at two examples just on how we use our trig ratios, our Sohcahtoa, our trigonometry functions, to find missing sides in right angle triangles. So in the first one it says find the lengths marked with the letters in each triangle. So the first thing you've got to do is label your sides. So relative to this 25, x is my opposite, so I'm calling it O. Also this 8 is my adjacent. So I haven't a clue which one I'm going to use, so I'm going to write down my Sohcahtoa to help me. So this will help me with my trig ratios. And I have got O and H. So I've got O and H. So you look at the three letters, group them in threes. The first three letters is SOH. The second three letters is CAH. The last three letters is TOA. So the one that involves O and A is going to be this one here. So it is going to be tan. So you write down that equation, that trig ratio. Tan theta is equal to O over A. And all you do is fill in what you know. So the angle theta is the same as 25. So tan theta is 25 then. So sorry, theta is 25. So tan 25 is equal to my opposite side was x and my adjacent side was 8. Okay, we bit of work to do here. What we want to find really, we want to find x on its own. We want to find what x is equal to. That's what we're looking to get to. So at the minute, we haven't got x on its own, we have got x divided by 8. Now the opposite of dividing by 8 is multiplying by 8. So this 8 effectively comes across and multiplies. So you'll have 8 times tan of 25 is equal to x. And then we'll just write that down. X is equal to, and x is equal to, on your calculator, make sure it's got a wee d showing it's in degrees mode. So 8 times tan of 25, press equals, and I have got 3.73. I've gone to 2 decimal places. The units would be centimeters, and that's to 2 dps. So there we have it. We have found our value of x. X was equal to 3.73 centimeters to 2 decimal places. Okay, this example, we have got the same idea, same thing to do. Well, the first thing you've got to do is label your triangle. So this side is the longest side. This is opposite my right angle, so this is my hypotenuse. I'm going to label it with an H. It's very small writing, apologies. I'm going to label that with an H, make it a wee bit bigger this time. This is beside the given side, so this is my adjacent. Again, I've forgotten all of my trig ratios. I would advise you to write this down every single time. Get this Sohcahtoa into your head, and then everything else falls into place after that. Right, we've got our A and we've got our H. So group these into threes. The first three letters is SOH, so it doesn't involve A and H. The second three letters is A and H, so it does involve CAH, so it does involve the A and H. So we'll just pick this one. This is the one we're going to use. And I'm going to just say cos theta. What CAH stands for is cos theta is equal to adjacent over hypotenuse. And then again, just like the last question, we're going to fill in. So theta we knew was 63. The adjacent is the side we're looking for, it's y. And the hypotenuse in this case is 9. So when we bring that 9 across, you'll have 9 times cos of 63, and that's going to be equal to y. And then when you do that to a few decimal places, 9 times cos of 63, close your bracket, press equals. What you're going to get is 4.09, and that's going to be meters, and that's going to be to 2 decimal places again. Okay, so in this video we were introduced to our trig functions, sine, cosine, and tangent. And the most important thing really from this video is Sohcahtoa, so how you remember which trig function to use. So you've got your trig ratios, you've got sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So where they come from is the three letters. So SOH, sine equals opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and the last three letters TOA, tan is equal to opposite over adjacent. So very, very easy to use. But every time you do the questions, I would advise you write Sohcahtoa down, and then draw your triangle out, and then label your triangle correctly putting on the correct two letters, and then you will know which trig ratio to use using your Sohcahtoa.